Hello everyone. I think we need to move on to the next, the exercise 3F of our New General Mathematics Book 1. Please kindly get your own and follow through the class as we move. So we are going to be solving the number 2 of the exercise 3F, 3 out of about 10 or 12 questions that are there. So we will be solving question 2A, 2F, and 2H. The instructions there is that we should find the HCF, now HCF, of the following. So don't forget, we started from finding the factors, finding the prime factors, then finding the common factors. Now we are now finding the highest common factors. So we are moving in a sequential manner. So how do we find the HCF of the following number? The first of them is 18, 24, and 32. How do we find the HCF of it? We said solution. Finding the HCF of this has in fact, we have numerous methods of solving the HCF of two or more numbers, but we are going to take the easier one. Don't forget, our motive in this class is to simplify things for ourselves. So we take the easier part. So how do we get the easier? But this easier part seems to be common, but it is not usually common to the HCF. So we use this. It is also called factor method, but it is mostly used in LCM, lowest common multiples. We are here to get to that, so we'll be talking about that when we get to multiples. So, but we can also use this method to find the HCF of two or more numbers. But the only thing is that the conditions will differ from that of the LCM. So let's start. We have 18, we have 24, and then we have 32. The condition here is that we are going to find a prime factor, so to say, that divides all the three numbers. Unlike the way it is done in as regards to LCM, at least one prime factor that can divide at least one of the three numbers will be used. But in this case, it is a prime factor that can divide all the three numbers that will only be used. So from what we have here, it is believed that 2 can divide all these three numbers without the remainder, and that is what we are going to use. So we use 2. 2 in 18, that is said to be 9. 2 in 14, 2 in 24 is said to be 12. Then 2 in 32 is said to be 16. So can we still use 2? Can 2 divide all these three numbers, 9, 12, and 16? I think the answer is no. So we will cease using 2. So we move to the next prime factor, which is 3. 3 can divide all the three numbers. 3 cannot even divide all the three numbers, because 3 can't divide 16. And so we can't use 3 either. So what else can be used? I think nothing can be used again. Can we use 5? No, we can't use 5. We can't also use 4, because 4 can't divide 9 without any remainder. So in this case, when we don't have any number except 1, because 1 is a number that can also divide all, but 1 will not make any difference in our results. So that is why we will not recognize 1. So we now say, therefore, the LCM of the three numbers is what? 2. That is it. It's just simple as that. So the B part, the F, now not the B. We are not solving the B. You are the one that will solve that for myself. So we have 30, we have 45, and then we have 75. So what can divide this number? What prime factors can divide this? So we can't use 2, because if a 2 can only divide 30 without remainder. So we can't use 2. Can we use 3? I think 3 can be used. So we use 3. 3 in 30, that is 10. 3 in 45, that is 15. And then 3 in 75, that is 25. Can we still use 3? No. 3 can only divide 15 without remainder. So we move to what? 5. 5 can divide everything. 5 in 10, that gives you 2. 5 in 15, we have 3. 5 in 25, we have 5. Do we still have any number that can divide except 1? And don't forget, 1 will not affect our result. So therefore, we say HCF will be 3 times 5, and that is what? 15. So we move to the last part of the question. So let's think. We move to the last part of the question, which is H. It has a bigger number. So it is the same way we will use in solving it. So we don't need to be scared in this. So what number can be used here? We dare not use 2 because 63 is there. So we have to use 3 either. So we use 3. So 3 in 36, that gives you 12. 3 in 72, that gives you what? So let's do 3 in 7, we have 2, remainder 1 in 12, that is 4. So 3 in 63 is 21. Can we still use 3? Yes, of course we can. 3 in 12, we have 4. 3 in 24, we have 8. Then 3 in 21, we have 7. Can we still use 3? No. Can we partially use 2? No. Yes, but 7 is there. 7 is there. So another thing that can is just 1, and that will not affect our final result. So therefore, we said the HCF of the set of number is 3 times 3, which is what? 9. And that is it about HCF. That is it about it. We can also use, there are many methods that can be used. You can use the arc method, but that may be too long for us. But don't forget, we are following the path of what? Easy. As it is stated in our religion, let's make things easy. Make things easy, and these are the easy ways we have adopted. Thank you for watching.